To me, volcanism is important to study because it is one of the most common and fundamental geologic processes that occurs in our solar system. It's a window into the history of our own planet, of the moon, and the other planets and moons in our solar system. My name is Brent Garry, and I'm a geologist at NASA Goddard Space Flight Center. I specialize in planetary volcanology, so it's my job to study the evolution of volcanoes and lava flows in our solar system, primarily on the Earth, the Moon, and Mars. What we're trying to answer is, how did these volcanoes evolve over time? When did they erupt? And kind of what went on during the eruption process itself. When we get images back from the moon of these long, meandering depressions called sinuous rills that look like rivers here on Earth, we want to understand, are these the remnants of collapsed lava tubes? Did the lava carve its way into the surface of the moon to leave these giant channels? Or in the case of Mars, the debate is whether or not these were carved by water or fluvial activity, or if they're carved by lava flows or volcanic activity. One of the best ways to answer these questions is by comparing the information and data we get back from the Moon and Mars to geologic features that we have right here on Earth. One of the exciting parts of my job is I get to travel around the world. I get to go to New Mexico, Hawaii, even Iceland to do my research. I love this part of my job because I get to hike up volcanoes all day. We're hiking around desolate, fields of lava. We're taking helicopter rides over these flow fields. We're looking at active lava flows that are going on, and even collecting samples of these features to study.
Don't try this at home, kid.
Our field team uses a wide range of instruments to do our work. We use things like a differential GPS, which gives us the topography of the lava flows. We use a ground-penetrating radar, which allows us to see in the subsurface of the flow field. And we also use a thermal imaging camera, which allows us to see the differences in temperature across an active lava flow. A lot of people might think that studying geology is just looking at boring rocks all day, but my job here at NASA proves that geology is an adventure. It takes you around the world and also to the surfaces of other planets and moons in our solar system.